Good afternoon, guys. This is Professor David J. De Los Reyes. Okay, I got a new topic this afternoon. For those who are serious in integral calculus and you are following my channel, I got a new topic this afternoon. This will be an application problem of the so-called computation of length of arcs. Okay, let's proceed. This is now lesson number 88 on my channel under the topic integral calculus, subtopic length of arcs. And for this afternoon, this is a very nice problem, okay? It will be the length of e to the x arc. We are given the exponential equation e to the x, and we are given 2 points on the exponential equation. And the problem is asking for the total length of the arcs between those 2 points. Okay, let's proceed. I will try to read the problem. Find the length of the arc. The arc is actually an exponential equation. Y is equal to the e to the x. This e here is the value e on your calculator, 2.71828. Okay? Y equal to e to the x from the two given points. A with coordinates 0 and 1 and B equal to the coordinates 1 and E. So the number one procedure and how to solve this one is to figure out what kind of graph is the given equation. It is an exponential equation. If I will see that the graph is something like this, it's just like the vertical upright path of SpaceX of Elon Musk. It is something like this. Okay. So actually, this is a very interesting problem. Initially, the SpaceX for Elon Musk emanates from this or start from this, then it goes vertically up. It's not actually vertically immediately. It will take a moment before it will go vertical. And the equation of that is y equal to the e to the x. Interesting? Okay, we'll try to graph the equation. This is a simple equation. To graph this one, we will just try to compute for the so-called intersection of this graph here with respect to the x or the y and x-axis if there are any. Okay, let's proceed. From the equation y equal to e to the x. Okay. If x is 0, y will be e to the 0. Okay? And e to the 0 is 1. Any number raised to 0 power is 1. Meaning this equation here passes through the y-axis at this point here. Okay? When x is 0, the value of y is 1. Okay? Let's change the value. When x is equal to 1, okay, what will be y? Y will be equal to e to the first power. E to the first power is just e. And the value of this is approximately 2.72. If you bring out your calculator, 2.71828. Meaning of this, when x is 1 unit, the value of y at that time is 2.72. So if this is 1, this is 2, this is 3, 2.7 is something here. So actually the second point is actually this one here. And the coordinate, the second point is actually b is equal to 1 and e. Meaning the abscissa, this point here is 1, and the ordinate is the value e, which is approximately 2.72. So actually the problem is asking for the total length of this graph here from this point here up to this. The one with the cross x. Okay, the problem is asking for that one. So I think we could solve this one. Okay, let's proceed with the solution. So we now know the graph. The graph is something like the path of SpaceX of Elon Musk. It goes vertically up. Initially, it got an inclined thing like that, then it will go vertical. Okay? You see? Oh, this is now a very interesting application of integral calculus, okay? So if we try to bring out the differential equation for taking the length of arc, differential length of arc is the square root of 1 plus dy dx quantity square times dx. Okay? We will use the first one. Anyway, we are given y equal to e to the x. So this is differential x. And we are now given y equal to e to the x. So it coincides with this dx here. Okay? Since y is equal to e to the x, we'll compute for dy dx. dy dx will be e to the x times 1, or just simply dy dx is just equal to e to the x. Right? Square in both sides, dy dx quantity square will be e to the x quantity square. Or the square of dy dx will be e to the 2x. X times 2 will be 2x. So the exponent of e now will become 2x. Okay? So if we try to go back here, differential length of arc will be the square root of 1 plus e to the 2x times the x. Unluckily, this is not integrable for the meantime. Okay? Because, what do you call this? This got a square root, and inside we got an exponent. But if we take the differential of this, we are lacking something, so it will not pull under the exponential thing, right? So we will try to bring out the correct solution. I think the solution will be the trigonometric or algebraic substitution. We try to simplify the one inside. First substitution will lead e to the 2x equal to z. Taking the natural log of both sides, 2x natural logarithm of a equal to the natural logarithm z. We bring down this one, okay, natural log, okay, then we will take also the natural log of both sides, but the natural logarithm of a is actually 1. So what will come out is actually 2x equal to the natural logarithm of z. Taking the differential of both sides, 2 dx equal to the differential of natural log is 1 over z times dz, or just simply dz over z. Computing for dx, dx will be dz over 2z. We go back here, ds now, we substitute this one, we'll go back there, yeah. So we'll see if it will become simplified. What will come out will be ds equal to the square root of 1 plus z. The 1 e to the x will now be z times dx, which is dz over 2z. So differential length of arc is actually 1/2 times the quantity the square root of 1 plus z over z times dz. Unluckily, this is not yet integrable. Okay? So bring out again another solution to make this simpler. So we bring out our second substitution, trigonometric substitution. That's why I saturated you with the integration techniques before going with the application. So whatever integration you will need under the application, just bring it out. Okay? We will try to simplify this one. We will let the square root of 1 plus z equal to y. Okay? Another substitution. This is variable y. First one is z. Squaring both sides, y square now will be the square root of 1 plus z. If we try to take the square, it will just be simply 1 plus z. And in here, we can compute for the value of z. Z will be y square minus 1. Later on, we need this one. Okay? So if we try to go back here, we take this value here, we bring it here. Okay? But let's try to take the differential first. taking the differential of this, 2y dy equal to, differential of 1 is 0, the differential of z is dz. We will put the value dz and z back here. Okay, so what will come out will be differential length of arc, we are following this, equal to 1/2. Square root of 1 plus z is actually y. And the value of z is y squared minus 1. We are following this. Times dz. What is dz? It is 2y dy. And luckily, these two here cancel with this. So ds now as a function of y, the second substitution variable, ds will be y squared. Y times y is y squared times dy all over y squared minus 1. This is second power. Take the so-called, divide the numerator and denominator the longhand way. What will come out will be, we got the 1 here, and the resulting equation will be 1 over y squared minus 1 times dy. Then try to take the integral. Okay? Integrable. But this one here, it falls under so-called partial fraction under case number 1. 1 over y squared minus 1. Y squared is factorable to y plus 1 and y minus 1. There are two factors. So we could take the equivalent of this. For it to be integrable as simply a over y plus 1 plus b over y minus 1 plus quantity dy. Solving simultaneously a and b, equating coefficient of like terms, we pass by the integration of partial fraction. Okay, I will show you the complete solution. What will come out for a will be negative 1/2, b will be 1/2. We now know a, we now know b, bring it here. So ds now will be dy plus a is minus 1/2 over y plus 1 plus b, which is 1/2 over y minus 1 plus quantity dy. This is integrable. Okay, this is integrable. They both fall under the natural logarithm. Okay, and the integral of dy, it's just y. So the integral of ds will be s, the integral of dy will be y. And if we try to take the integral of this, after the simplification, I will not show you the complete expansion. I will lack space. Should be 1/2 the natural logarithm of y minus 1 over y plus 1. They should be under the numerator and they should be under the denominator because this is minus. Because the logarithm of a quotient will be a logarithm of a difference. So it should be 1/2 the natural logarithm of y minus 1 over y plus 1 plus quantity. But this is not yet the final answer for the integration. Because the variable here is y, it is the variable on the second substitution. So we will bring out the equivalent of y in terms of z. So y is actually the square root of 1 plus z. Where is that? Y. Where is y? It is this. Okay? So bring out the original variable. Plus 1/2 the natural logarithm of the square root of 1 plus z minus 1. Square root of 1 plus z plus 1 plus quantity. But z is not the original variable, it should be x, right? But we know the relation of z in terms of x. Where is that? It is this. Okay? The original variable of the ds is actually x. So we all z replaced by e to the 2x. So this will be the square root of 1 plus e to the 2x plus 1/2. The square root of 1 plus e to the 2x minus 1. Square root of 1 plus e to the 2x plus 1 with the limit. The problem is asking for the total length of this curve here from points A and B, and we are integrating with respect to x. So our limit will be from x equal to 0 till x equal to 1. So the lower limit will be 0, upper limit will be 1. So this is after the integration, first substitution, second substitution, this is the s in terms of x with the limit from 0 to 1. I will not show you the complete simplification of this, okay? Just place 1 for x on the first one, take your calculator, okay, do it on a rough draft. What will come out for the upper limit will be 2.536. For the second value, all x replace it by 0. Take your rough draft. Use your calculator. What will come out for the lower limit will be 0.533. Okay? On your rough draft. Okay? So S now will be 2.536 minus 0.533. S now will be 2.003 units. How it seems? The total length is 2 units. Right? Oh, you can see it? It's 1, it's 2. Because this is 1 unit, this is 1 unit. If you see it from the graph was correctly, what you call this, scaled. Okay, I make it a point that it was scaled. So this is 1 unit, 2 units. So approximately S, the length of e to the x from this point here to this is 2 units. Supposing the problem will ask you the space x of Elon Musk flies after 30 minutes, how high is the space x of Elon Musk from the ground? The problem could ask you that one, guys. It is still the length of Earth. And the solution should be something like this. You see? Okay, I will try to erase this one so you will understand it. X, Y, Y. This is the fat of the SpaceX of Elon Musk. And the equation is y equal to e to the x. The problem could ask you how high is the SpaceX of Elon Musk after 30 minutes. Maybe it's here. And what will be the height at that time? Okay? So that's the significance of integral calculus in science. They are using it. Okay? Good afternoon, Los Angeles.